Good morning. Today we are going to cover section 9.5. We are going to cover the quadratic formula. Now, we are going to continue solving quadratic equations. So how do you find the solutions of a quadratic equation? But now we are going to use a quadratic formula. So take the time to write your essential question. You can paste your cutout and then start on question number 1. Pause it if you need more time. So it says, the quadratic formula is a formula, just like you guys have your area formula for a triangle. We have a formula to find the solutions of a quadratic equation. In the formula, you need to have your equation in what we call standard form. You have your x squared, then your x, and then your constant. And it has to be equal to 0. Therefore, the real solutions, are going to be given by the following. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And if you notice, this part of the formula is what we cover. Do you guys remember the name? So what is the name of this expression? B squared minus 4ac. That was on your last set of notes. It's called the discriminant. So write it down. And the discriminant tells you how many solutions and the type of solutions. So when we work this out, we want to make sure that we work it out separately. Notice that we don't want a to be 0, because if a is 0, your denominator is 0, and then we have an undefined solution. Also, whenever you have 0 for your a, that means that your x squared is no longer there. That means that you have a linear equation. Once we have an x squared, we have a quadratic equation. And notice that we want b squared minus 4ac to be greater or equal to 0, because it's inside the square root. And we'll talk about that in a few minutes. So let's start with problem number 1a. Now notice that one of the things that I prefer to do is to first label my equation, make sure that it's on standard form, x squared, x, and then the number. And I'm going to label it. This is a, this is b, and that is c. And I'm going to write down my equation. I'm going to set it up. So I'll replace the b with parentheses and the a in parentheses. And my b squared minus 4ac, I'm going to do it separately, not at the same time. And that'll make it much easier for all of you guys. We have x equals negative b plus or minus square root. This will be separately all over 2a. So this part is going to be your discriminant. And your discriminant is going to tell you the number and the type of solutions. So let's write down your discriminant. It'll be b squared minus 4ac. And let's set it up just like we did on the last lesson. B squared minus 4ac. And we'll come back to that in a second. So let's say x equals negative b. B is 5 plus or minus square root all over 2a, where a is 2. Inside the square root will be b squared. So your discriminant is 5 squared minus 4. A is 2 and c is negative 4. I'm going to simplify this out. 5 squared is 25. Just the same thing as that we did in the last lesson. Those two numbers are multiplying, all three numbers. So I'll multiply those two numbers. It gives me a negative 8. And the negative 4 are still multiplying. So we have 25. Negative times a negative is a positive. 8 times 4 is 32. So it'll be 20, 57. That is that discriminant is positive, which means that we have two real solutions. Correct? And that's what we did last time. So therefore, now one of the reasons that we have two real solutions is because of the plus or minus. That's going to be 57. And now I just need to be able to take an extra step to simplify. So we have x equals negative times 5 is negative 5 plus or minus, and that will be square root of 57. Cannot be simplified. Even 57 is a prime number, so we cannot do the factor tree. There are no perfect squares that divide 57. 2 times 2 is 4. Those are my solutions. Now, if I want to be able to find my solution, I'm going to use my decimals calculator. So calculator, I like to use my decimal scientific calculator. That one will be easier to type in that, and you guys can use this for your homework. So I'm gonna type in the first one with a positive. So I'm gonna use my fraction bar, and it does have a fraction bar, which is and that's the first thing I'm gonna type in. And I'm gonna type in negative 5 plus the first one will be with a positive plus the square root of 57, and then I'm over 4. So therefore, my first solution will be x is approximately 0. Let's do two decimal places, 0.64. That's my first solution. And let me just press enter. And let me do another one with them. Actually, I'm just going to go in here. And what's nice is I can go back and just type in with a minus. And therefore, my other solution is approximately negative 3.14. So we have two real solutions. Now I'm going to go into my decimals calculator, and I'm going to type in my equation. 2x squared plus 5x minus 4. And notice I don't want to place, I can place, if I place equal to 0, it's going to give me a different line. I don't want to place equal to 0. I can place y equals instead, either or just leave it without. And now you should be able to see that my solutions should match. Correct? So that's what we're trying to find. We're trying to find out where it crosses your x-axis. And most of the time you guys will see it as this as part of your answer because this is an exact answer. These ones are approximation because we are rounding off. And that's all we're doing today. Let's do the second one. And that way we can do a little faster now that we know the process. We want to make sure that it's on standard form. So we have x squared, x, and then the number. In this case, it's an equation, so equal to 0. So A, B, and C, we are finding the solutions. And I'm going to set up my formula. X equals negative B plus or minus square root all over 2A. And I prefer to set up that part first. So X equals opposite B. B, there's no coefficient here, but we know that there's a 1 that's hiding from us. So X equals negative 1 all over 2A, which is 3. In here will be your discriminant. Your discriminant will tell you the number in type of solutions. So this one was positive, so it was two real solutions. And the formula is b squared minus 4ac. And you can just say it up if you want to write down the first time. B is negative 1, A is 3, and C is 1. And I just need to be able to simplify. Negative 1 squared is negative 1 times negative 1, which is positive 1. I'll multiply all three numbers. Negative 4 times 3 is negative 12, and then times 1. Negative 12 times 1 is negative 11, negative 12. And 1 minus 12 is negative 11. That is negative. And according to the last section, if it's negative, we have no real solutions. And that negative goes inside the square root. And remember, the reason now we can actually understand why there are no real solutions, because you cannot take the square root of a negative number. So basically we say no real solutions. There are solutions, but you guys will be covering that in Algebra 2, where we have talked about imaginary solutions. So every time imaginary solutions instead of real solutions. So every time your discriminant happens to be negative, then you don't need to do anything else, because we know that that discriminant goes inside the square root, and we cannot take the square root of negative number in Algebra 1. So in this case, we have two real solutions, and we were able to find them. If there are no real solutions, we don't have to follow through the next steps. We are done. Example number 2. Go and take the time to copy it down, and then we'll continue once you are ready. Go and pause it if you need more time. So it says, find the x-intercepts. So notice that on the previous one it says solve, which will be the same thing. Oh, and actually, let me go back to this. Let's go and graph it so you guys can see. And we talked about this last time, but let me just go and graph it before I forget. 3x squared minus x plus 1. Notice that it doesn't cross the x-axis at all. So that's why there are no real solutions. We still have solutions, but they're complex, imaginary. They're imaginary and complex solutions. But for now in Algebra 1, if it doesn't cross the x-axis, we said that there are no real solutions. And the keyword is real. We only were working with real numbers in Algebra 1. Example number 2. Now we find the x-intercepts, right? Which is the same thing. In this case, there were, in the previous example number 1, there were two real solutions. You cross the x-axis twice. So the process will be exactly the same. We're using the quadratic formula once again. We have x equals opposite b plus or minus square root all over 2a. And where this is my a, my x is my b, my coefficient, and my c is my constant. So x equals negative b, b is negative 8, plus or minus square root all over 2a, which is 1. This part will be my discriminant, which is b squared minus 4ac, b squared minus 4ac, where b is negative 8, a is 1, and c is 5. Negative 8 squared is negative 8 times negative 8 is positive 64. Remember, you also square in the negatives. So 64. I'll multiply those out. Negative 4 times 1 is negative 4. And the 5 still multiplying. So I'm still multiplying those two numbers. So it gives me 64 minus 20, which is 44. 44 is positive, which means that they are two real solutions. And that goes inside the square root. Negative and negative becomes a positive, so it gives me x equals 8 plus or minus. Now the square root of 44, we can simplify square root of 44. We can do the factor tree, or we can say which perfect square divides 44. So let's do the factor tree. So it gives me 4 times 11. 4 will be 2 and 2. That's prime numbers. 11 is a prime number. So notice that you have two 2's inside. So 2 times 2 is 4. The square of 4 is 2. And the square of 11 stays inside. So this will be 2 square root of 11. All over 2 times 1 is 2. We can simplify it. We can actually divide the a by 2. So a divided by 2 gives me 4 plus or minus. 2 divided by 2 is 1 square root of 11. And I don't need the 1 in here. So I usually don't write it down. It's like a coefficient that's hiding from you. So in these steps, you can simplify the square of 44 as 2 square of 11. And then we can divide each one by 2. And now we have our solutions. Let me go into so I have 4. One will be with a plus the square root of 11, which is 7.3, approximately 7.3. Let's do 2 decimal places, 7.32, since that's a 6. And the other solution, x is approximately, we're going to do 4 minus the square root of 11. So it'll be 0.68. And if I go into my Desmos calculator, graphing calculator now, and I type in the equation, that should match. That should be where it crosses your x-axis. Let's find out. So notice that we do have a parabola. We can move this down if we want to see a full graph. And one of them is 0.68, the other one is 7.32. So those are your x-intercepts. Well, on the previous one, when we have an equation, we just call them the solutions. Let's try one more and see what you get. So come and pause it. See if you can work it out by yourselves. You want to be able to set up first. X equals negative b plus or minus square root all over 2a. And you can sing it as you go. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So work it out. Then find your discriminant on the side. It makes it a little bit easier. In some of the, if you look up some of the solutions or how to get help on YouTube, sometimes they do it inside and it takes just a little few more steps on the side. So I prefer to write it down separately, but you can do it all at once at the same time. Your discriminant will be b squared minus 4ac. So first see what you get, and then pause it, and then we can compare. You ready? So we have a, b, and c. This is on standard form. So b is negative 7. So once again, I have a double negative. All over 2a, which is 5. And now, inside the square root, b squared minus 4ac. b is negative 7 minus 4. A is 5. And c is 2. Negative 7 squared is negative 7 times negative 7, which is positive 49. That gives me negative 20 and times 2. So it gives me 49. Negative 20 times 2 is negative 40. So it gives me 9. So therefore that goes inside the square root. Now that is a perfect square. That means that we're going to simplify nice and neat in two different numbers. Might end up with a fraction, but still will be better than decimals. So we have x equals negative and negative. We can say positive. We have double negative, plus or minus. The square of 9 is 3. Well, on this one, we have to be able to do the factor 3. In this case, 9 is a perfect square. 2 times 5 is 10. And therefore, we can separate, especially because we have two solutions. We can use a calculator, or just like we did on this problem, or we can actually just write x equal to 7 plus 3 divided by 10. So therefore, x equals 7 plus 3 is 10 over 10. So x equals 1. And now one with a positive and one with a negative. 7 minus 3 is 4 over 10. And I can reduce it by 2. Divide by 2 gives me 2. Divide by 2 gives me 5. Or somebody can say, DS, can I just use a calculator at that point? Sure, but it's actually, I feel like it's more work. So I'm going to use my calculator, my decimal scientific calculator, to type in the first one. And I'm going to type in, let me use my fraction first. 7 plus 3 divided by 10, which is 1. And 7, let me use my fraction bar first. 7 minus 3 divided by 10. And gets me. And notice that in this symbol, you can convert to a fraction, 2/5, or come back to a decimal. So they both are correct. And if I graph it, if I take the time to graph it, let me just retype the entire equation. We have 5x squared minus 7x plus 2. And it's up there. You can zoom in. What's nice about decimals, and you have your two solutions. Now remember that was 0.4 and that is 1. So that is the quadratic formula. So now let's go and do a quick review. Example number 3. We kind of done this similar, but now we can throw in the quadratic formula in there, where on the previous one, we know how to solve by factoring, by completing the square, by square roots, and by quadratic formula. By factoring, we covered on the last chapter. Completing the square was 9.3. By square roots was 9.2. And this is 9.5. Go ahead and copy A, B, and then we can work it out together. And then pause it, and then we'll start once you're ready. Now, when we have a quadratic equation, we can solve it in different ways. Now, we are going to factor it first. Remember, by factoring, we use our double parentheses equals 0. What are the factors of x squared? X and x. What are the factors of negative or positive 12? Let's see, 12 times 1, 4 times 3, or 6 times 2. Anything else? No. Now that's a positive 12, so they need to have the same sign, both positives or both negatives. They need to add up to a negative 8x. So therefore they both should be negative. We know that for sure. So which one should I use? Correct. I should use 6 and 2. And now I'm going to use my zero product property to solve it. So now I'm going to use my zero product property because they're multiplying and they equal to 0. Either x minus 6 equals 0 or x minus 2 equals 0. And now I can solve it. Plus 6 on both sides, so move my 6 to the right becomes a positive 6. So therefore x equals 6. Move my 2 to the right becomes a positive 2. So therefore x equals 2. Now by completing the square, it's a process. To complete the square, I'm going to leave my x's on the left and I'm going to move my constant to the right and I'm going to leave some space with the square. So we have x squared minus 8x. I'm going to leave some space to complete my square equals, and that becomes a negative 12. And what I do on one side, I need to do to the other side. Now, do you remember what number goes in here or what formula to use? Remember, your formula is b over 2 and then square it. You take half of b and then square it. So what's half of negative 8? Negative 4. And negative 4 times negative 4 is positive 16. And now I'm going to factor this out. This should factor nicely, and this should always be the same when you complete the square. X and x, factors of 16 will be 4 and 4. They need to have the same sign. They need to have to a negative 8, so the both should be negative. Negative 12 plus 16 is 4. And now I'm going to combine them both into 1. X minus 4 squared equals to 4. And now I can take the square root on both sides to get rid of the square. I'm going to take the square root on the left and on the right. My square root and my square cancel, so now I have x minus 4 equals, 4 is a perfect square, so the square root of 4 is 2. But let me not forget my plus or minus. And now the last step to leave the x by itself, move my 4 to the right, we can say positive 4. Remember that we're going to place it right after the equal sign. And we have plus or minus 2. So therefore, we're going to have two solutions. X equals 4 plus 2 and x equals 4 minus 2. So x 4 plus 2 is 6, which is the first solution. 4 minus 2 is 2. So which way do you prefer? Yeah, factor is much easier, but you cannot always factor a trinomial, and that's why we have other ways. I usually use completing the square if there's no coefficient. The coefficient is 1, and the b value is even. So that way I can take half of it. If it's an odd number, then and I cannot factor it, then I use the quadratic formula. And in Algebra 2, they're going to actually ask you to know what is the best way to factor or to solve it. In Algebra 1, we tell you ahead of time what you need to use. Well, for letter C, let's go and review what we covered today. Quadratic formula. X equals opposite b. X equals negative b plus or minus square root all over 2a. A, b, and c. X equals negative b. B is negative 8. Again, I have a double negative. All over 2a. A is just 1. Notice I'm not carrying down the x's, only the coefficients. Now, in here, inside the square root will be my discriminant, which is b squared minus 4ac. And I'm going to say that b squared minus 4ac, where b is negative 8, a is 1, and c is 12. Negative 8 times negative 8 is positive 64. So when you square it, you also square in the negative. That is negative 4 times 12. 64. Negative 4 times 12 is negative 48. And 64 minus 48 is 16. And now, this is positive. Your discriminant is positive, that means that you have two real solutions. But in this case, we're just going to plug it in there. So we have x equals negative and negative becomes a positive 8. Square of 16, that's a perfect square. So therefore, square of 16 is just 4. We don't need to do a factor tree. And that gives me 2. And now I have my solutions. You can simplify each one by 2 if you want, just like we did on example number 2. Or we can say a plus 4 divided by 2. So it gives me 12 divided by 2, which is 6. Same thing that we got on the first. And then x equals 8 minus 4 divided by 2. So x equals 8 minus 4 is 4 divided by 2. So x equals to 2. And that's what we got on the second solution. So whether you do it one way, another, or the quadratic formula, so which one will be easier? Correct. This will be factoring if you are able to factor it. And notice that if you use your graphing calculator, another way to be able to find the solutions is just by using your graphing calculator. So if I just use my graphing calculator, that is another way, and that's what we did on the last chapter. Plus 12. Now I need this to zoom out, hide, and those are my solutions. So one way is by factoring, completing the square, quadratic formula, or by graphing, we can see where it crosses your x-axis, and those are your solutions, your x values of the x-intercepts. And another special manner to, or different way to solve quadratic equation, if they're on different forms, such as this, I can solve it by square roots, where I can just leave the x by itself. I need to get rid of the 5, the 2, the square, and the negative 7. First, I'm going to move my negative 7 to the right, or you can add 7 on both sides. That gives me 5x squared equals 100. I need to get rid of the 5 in the square. I'm going to divide by 5 on both sides first. X squared equals 20. And the last step is to get rid of the square by taking the square root on both sides. My square root and my square cancel, so therefore x equals. To simplify square root of 20, you can do it two ways. You want to use your factor tree or your perfect squares. I'm going to use my perfect squares this time. So which perfect square divides 20? 4. So square root of 4 times the square root of 5 gives you 20. The square root of 4 is 2, and we have a square root of 5. But I forgot something. Correct. I need plus or minus. Now sometimes you guys will see your answer as this. Sometimes you guys will see as separated, where we have x equals to 2 square root of 5 and x equals negative 2 square root of 5. And sometimes you guys clearly will see it as a decimal. So we can just type in 2, the square root of 5, and we're going to send an approximation to decimal places, 4.47, and with a negative, negative 4.47. So there's 3 different ways that you might be able to see your answer on a SAT or PSAT. They get to you as a combined plus or minus 2 square root of 5, separate one positive, one negative, or the decimal equivalent of each one if they allow you to use a calculator. So those are the different ways that we cover quadratic equations. Email me if you have any questions on your homework, and I'll see you guys next time.